The question, and please read it for a moment and try to solve it on your own. And then in a couple moments, I will solve it and we can find out if our answers are the same. And this problem is challenging, but I just want to not remind you, but this is going to be a standard problem, so it's possible that you will encounter this on the AS level examination or one of my exams. And here I want to remind you of the equation of a circle where HK is the center. HK is the center of the circle, and R squared, that's the radius. All right, not the prettiest circle, but I encourage you to sketch it so you can visualize it and then go from there. All right, so what our goal is not to find this line, AB. We're trying to find the perpendicular bisector. So think about this. If this is AB and we find the gradient or the slope for AB, then we want to find the perpendicular bisector of AB, and it's going to come right across this circle. And if we find the perpendicular bisector of, say, for instance, BC, you can imagine this line's like that, and then we come across, and we're going to find the center of the circle. And that's what we're trying to do. Well, we're trying to find the equation. So we're starting out with the center, and then we'll find the radius after that. Okay, so I found the equation of the gradient for AB, and it's -1. And the equation of the perpendicular line of AB is +1. So remember, take the negative inverse of the actual gradient to find the perpendicular gradient. And now we find the midpoint. We've been through this before, but not in the context of circles. But remember, we're trying to find the perpendicular bisector of this line. That's the only way. I'm trying to make the vocabulary a little simpler, but that's what we're trying to find. So we've got AB, and we're trying to find the bisector. So we're trying to find this, and then we're going to find this, BC, where it crosses, and the middle should be up here more. The middle is going to be the center of the circle. And when you find the solution, you get y is equal to x, because you find -7/2 and add it to both sides. You find out that b is 0, and the slope is 1, the gradient is 1, and there's an implied 1 here, and 1x plus 0, and then you just find that y is equal to x for AB. All right, so at this point, what I'm trying to find is I'm trying to find this. I'm trying to find BC to find out where these lines intersect, and I went ahead and found the slope of BC, or the gradient as they call it. I found the reciprocal, or the inverse, and I found the midpoint. And then I went ahead and I'm trying to solve B for the inverse, for the perpendicular. So the perpendicular bisector and the y-intercept is -6, and here's the equation I got. So what I'm gonna do now is we can look at our old equation, not the old equation, but what I mean is AB, and that's y equals x. And BC is y is equal to -1x minus 6. When I say BC, I mean the perpendicular bisector. So now I'm going to substitute. So BC is this. BC is equal to y is equal to -x minus 6. And AB is equal to y is equal to x. And now I can substitute x in for y, and I have x is equal to negative x minus 6. And we find out that x is equal to negative 3. Yeah, and sorry, this problem is a bit exhausting, but you can substitute negative 3 in for x, and then you can find y, and we can use this one. I like this one because it's easy. So y is equal to x, so that means that y is also equal to negative 3. So we found the center. The center is at negative 3, negative 3. And now we've come full circle back to where we began. And we're going to put negative 3, negative 3. We've already established that's where the center is. So we're going to go ahead and put a negative 3 in for h and for k. So we've got x plus 3 squared plus y plus 3 squared is equal to r squared. We're almost there. We just have to figure out what r is. So we found our center, which is negative 3, negative 3. And if we come back to our old friend, the distance formula, then we can find out what the radius is. We just have to leave it as we can't square it because this is how the equation is written. And with this particular equation, it comes out neatly. And so we wind up with, I used point A for this to determine the distance, and we get positive 1 here, and we square it, and we get 0 here, so we just get 1, and the square root of 1 is 1. So our final answer is this, where negative 3 is the center, and 1 is going to be the radius of the circle, and we're finished.